Milk powder may look like a simple dry ingredient, but behind each scoop is one of the most carefully controlled dehydration processes in the food industry. What begins as fresh liquid milk, highly perishable and sensitive to temperature, is transformed through filtration, heat treatment, evaporation, and precision drying into a stable powder that can last for months or even years without refrigeration. Every particle must dissolve easily, retain nutritional value, and taste clean and fresh when rehydrated. And today on the How Factory, we're stepping inside large-scale dairy plants to see exactly how milk powder is made, from fresh milk to long-lasting powder. The development of milk powder was driven by a simple problem. Fresh milk spoils quickly. Before refrigeration and modern logistics, transporting milk over long distances was nearly impossible. In the 19th century, early drying experiments showed that removing water dramatically extended shelf life. Over time, improvements in heat control and spray drying turned milk powder into a reliable global commodity. Today, milk powder is used in infant formula, baked goods, chocolate, beverages, emergency food supplies, and countless industrial applications. The process begins at the dairy farm. Fresh milk is collected from cows and immediately cooled to slow bacterial growth. Milk is highly sensitive, so temperature control starts within minutes of milking. Refrigerated tanker trucks transport the milk to processing facilities, often within hours. Throughout transport, temperature and cleanliness are monitored continuously. When the milk arrives at the plant, it undergoes intake inspection. Samples are tested for temperature, fat content, protein levels, acidity, and microbial quality. Any milk that fails to meet strict standards is rejected. Quality at this stage determines the quality of the final powder because defects cannot be hidden once the milk is dried. Once approved, the milk is filtered and clarified. Clarifiers use centrifugal force to remove dirt, somatic cells, and other microscopic impurities. This step improves both safety and shelf life. The milk is then standardized. Standardization adjusts the fat-to-protein ratio depending on the type of powder being produced. Whole milk powder retains its natural fat content, while skim milk powder has most of the fat removed. Fat separation is achieved using centrifugal cream separators that spin at high speed. After standardization, the milk undergoes pasteurization. Pasteurization heats the milk to a specific temperature for a set amount of time to destroy harmful microorganisms. This step ensures food safety without significantly affecting nutritional value. Pasteurization also stabilizes enzymes that could cause off flavors during storage. Following pasteurization, the milk may undergo additional heat treatment, depending on its intended use. High heat or low heat processing affects protein functionality, which is important for applications like baking or infant formula. These heat treatments are carefully controlled to modify protein behavior without excessive denaturation. At this stage, the milk still contains about 87% water. Removing that water efficiently is the core challenge of milk powder production. Directly drying liquid milk would be extremely energy-intensive, so the process first concentrates the milk. Concentration takes place in evaporators. Evaporators remove a large portion of water by heating the milk under vacuum. Lowering the pressure allows water to evaporate at lower temperatures, reducing heat damage. The milk flows through multiple stages where steam heats thin films of milk, evaporating water rapidly. By the end of evaporation, the milk has thickened into a concentrated liquid containing around 45 to 55% solids. This concentrated milk now resembles a thick cream. Before drying, it may be homogenized. Homogenization breaks fat globules into smaller, evenly distributed particles. This improves powder stability, prevents fat separation, and enhances reconstitution properties when the powder is mixed with water later. From here, the process moves to spray drying, the most critical stage. Spray drying transforms liquid concentrate into fine powder in seconds. The concentrated milk is pumped to the top of a tall spray drying tower. Inside, high-pressure nozzles or spinning atomizers break the liquid into millions of tiny droplets. Hot air is introduced into the drying chamber, often at temperatures exceeding 180 degrees Celsius, 356 degrees Fahrenheit. Despite the high air temperature, the droplets cool themselves as water evaporates rapidly. This evaporative cooling protects heat-sensitive nutrients. As the droplets fall through the chamber, water flashes off, leaving behind dry milk particles. By the time the particles reach the bottom of the tower, they are mostly dry powder. The air carrying moisture exits the system, while the powder is separated using cyclones or filters. The entire drying process takes only a few seconds, minimizing thermal damage while achieving efficient dehydration. The structure of the powder particles is crucial. Spray drying creates hollow or porous particles that dissolve easily in water. Particle size, shape, and density are controlled by adjusting nozzle pressure, air temperature, and feed rate. These parameters determine how the powder behaves during storage and reconstitution. After spray drying, the powder may undergo secondary drying or fluidized bed processing. This step reduces residual moisture to very low levels, improving shelf life. In fluidized beds, warm air flows upward through the powder, keeping particles suspended and evenly dried. This stage also allows for agglomeration. Agglomeration improves instant properties. Fine powder particles are lightly re-wetted and encouraged to stick together, forming larger, porous granules. These granules dissolve more easily without clumping, making them ideal for instant milk products. Agglomeration is carefully controlled to avoid excessive dust or uneven granule size. Once drying and agglomeration are complete, the powder is cooled rapidly. Cooling prevents condensation and moisture absorption. Milk powder is hygroscopic, meaning it readily absorbs moisture from the air. Even small humidity changes can affect quality, so humidity control is critical throughout the plant. Quality control intensifies at this stage. Samples are tested for moisture content, bulk density, solubility, dispersibility, color, flavor, and nutritional composition. Microbiological testing ensures the powder meets strict safety standards. Any deviation triggers process adjustments or batch rejection. Different types of milk powder may receive additional treatments. Some powders are fortified with vitamins and minerals. Others may be blended to achieve specific functional properties for food manufacturers. Blending systems ensure uniform distribution of added ingredients without damaging the powder structure. Once approved, the milk powder moves to packaging. Packaging must protect against moisture, oxygen, light, and contamination. Even slight moisture exposure can cause clumping or spoilage. Packaging lines operate in low humidity environments to maintain powder quality. Milk powder is packed into a variety of formats, including consumer-sized bags, tins, and large industrial sacks. Automated filling systems weigh precise amounts, minimizing air exposure. Many packages are flushed with nitrogen to reduce oxygen levels and extend shelf life. Sealing systems ensure airtight closure. Date codes, batch numbers, and traceability information are printed automatically. Finished packages are boxed, palletized, and moved to storage warehouses. Temperature and humidity remain controlled throughout storage and transport. Behind the scenes, sanitation is a constant priority. Dairy plants follow strict cleaning protocols. Equipment is cleaned using clean-in-place systems that circulate detergents and sanitizers without disassembly. Preventing cross-contamination is critical, especially for products like infant formula. Sustainability plays a growing role in milk powder production. Evaporators and dryers are energy-intensive, so plants use heat recovery systems to capture and reuse energy. Water removed from milk during evaporation can be treated and reused. Byproducts such as cream are processed into butter or other dairy products, minimizing waste. What makes milk powder manufacturing remarkable is the balance between efficiency and protection. Milk contains sensitive proteins, fats, sugars, and vitamins. Removing nearly all water without damaging these components requires precise control at every step. Small errors in temperature, moisture, or airflow can affect solubility, flavor, or shelf life. From farm collection and pasteurization to evaporation, spray drying, agglomeration, and airtight packaging. Milk powder production is a continuous system designed for stability and consistency at global scale. And that is how milk powder is made: collected, pasteurized, concentrated, dried, cooled, and sealed, transforming fresh milk into a long-lasting powder that can travel the world and return to liquid form with just the addition of water. Thanks for watching the How Factory.